Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to provide an example of how to calculate potential difference between 2 points in a circuit. So what we're looking at here is this kind of mixed up circuit here that's got 3 batteries here. We've got a 30 volt battery, a 6 volt battery, a 12 volt battery. Right? We got various resistors here, 5, 2, 7, 4, and 2 ohms. And what we're going to do, just like I said, is we're going to talk about how to calculate the potential difference between A and B. All right, first thing I'm going to do, as usual, I'm going to color code my potentials. I'm going to go ahead and set a ground in this too. So I'm going to put a datum here. So a ground symbol just basically means I'm calling the potential here 0. So this is going to be one potential that's going to be good to this point. It's actually going to be good all the way to B. And the reason this is going to be good across this resistor is because these are not connected, so there can be no current through this resistor and therefore no voltage drop across it. So by putting a ground here, what I'm doing is I'm setting potential B equal to 0. And I'll go ahead and look for potential A, and then I'll have the difference between them. All right, so this is 30 volts higher, so I'm going to go ahead and make this potential red. That's going to be good just in this small region. Red potential I already know is plus 30. When we go across this resistor, we're going to drop in potential, so we're going to have a new color. That's going to be good up to this point and all the way to here. When we go across this resistor, we're going to drop in potential again. That potential is going to be good up to that resistor. When we go across this resistor, this one will have a current, so we're going to drop in potential again. And there we have it. So I've color-coded the potentials. Now, let's talk currents. This problem, no doubt, we're going to have a current in this branch right here. I'm going to go ahead and put that current here and call it I1. So that value of I1 is good anywhere in that branch. All right, once we go here, though, that current is going to be kind of divvied. Some of it's going to probably take this path, some this path. So I'm going to go ahead and call the current in this path I2. Current here I3. Now, the one we really need here is I1, because remember the question. I know potential B. I've put a ground here, so I basically have forced B to 0, or I've called the potential at B 0. I'm looking for potential A. I'm going to need the current across this resistor to know the orange potential. Red is no problem. Red is plus 30. But I need to know the drop across here to figure out the orange potential. Now, there's a couple ways to handle this. To get the potential here, I'm going to need the current I1. I could just kind of blindly write a system of equations and solve them, but whenever you can use the concept of equivalent resistance, you should. It's usually the easiest way to solve a problem. So what I'm going to do here is copy, paste, draw a completely new circuit picture. Let's shrink this down a little bit. And what I'm going to do is I'm going to replace this pair of resistors with their parallel equivalent. So basically I can just get rid of these. And in their place, I'm going to put a single resistor and call its value R equivalent. And it's going to be equivalent to this pair that's in parallel. Now to calculate that equivalent resistance, I'll do this down here. I've got 1 over 2 ohms plus 1 over 7 ohms is equal to 1 over R equivalent. That's because that's a parallel combination. And if I solve this for R equivalent, I got 1.56 ohms out of that. Now when you do a parallel combination, you know, your results should always be smaller than the 2 resistors in parallel that you're dealing with. So I've got some confidence that's probably good. All right, 1.56 ohms for the value of this resistance. Now, and you know one thing I should do here. That orange potential, actually, in this picture is good right to there. All right, now, and another thing is this is a closed circuit here. All right, now I can now write a loop equation here because there's really only one loop. So that loop equation, here's what it's going to look like. If I start here and I go around clockwise, I'm going to have plus 30, and I'm going to leave my units off. They're all consistent. Then we're going to drop in potential by an amount 5i, and again, that's IR. I just think it sounds better to write 5i than I times 5. Here we're going to drop in potential by an amount 1.56i. Now we're to the yellow. Here we're going to drop in potential by an amount 4i. And actually I should talk about which I here. We're talking I1s. These are all I1s in this picture. Here we're going to go up in potential by 12 volts. And then we are back to where we started. So this sum equals 0. All right, so now what I have here is I have an equation that I can use to solve for the current I1. If we solve for I1, I get 3.98 amps out of that. All right, I can write that a little better. 3.98 amps. So now we know the current I1. Now, going back to my original picture, what did I want that current for? I want it for the voltage drop across this resistor. The delta V, when we go from red to orange, do this from red to orange, is equal to the current 3.98 amps. Oops. Times the value of that resistance, 5 ohms. And when we calculate a value there, let's see. Now I get about 19.9 volts. Should have just probably approximate that to 20, but I'll go ahead and write 19.9 volt potential difference there. So our potential, our orange potential, oops. The orange potential is therefore equal to 30 minus 19.9 volts, which is 10.1 volts. So I know that my orange potential is 10.1 volts. Now, when we go down to here now, we're going to drop by 6 volts. So I should actually have a different color on that, to tell you the truth. That's a different potential. Let's make that blue. So my blue potential is now going to be my orange potential, 10.1 volts, minus my drop-in potential here of 6 volts, and I end up with, what, 4.1 volts for the blue potential. All right, so B is at 0, A is at 4.1 volts, so the difference in potential between them is 4.1 volts. Now, a lot of people, will probably ask, plus or minus. Well, it depends on how you look at it. I mean, the important thing is just knowing which one is at the higher potential. The difference potential between these 2 points is 4.1 volts, with A at the higher potential. So if this is potential B minus potential A, it would be minus 4.1 volts. If it's potential A minus potential B, it's positive 4.1 volts. The important thing is just knowing the potential difference between these is 4.1 and A is at the higher potential. So I hope that this video helps demonstrate how to calculate potential difference between 2 points in a circuit. Have a great day.